Slow, mysterious music begins. The screen fades from black to a breathtaking view of the Milky Way stretching across the night sky. There are few questions more profound than this. Are we alone in the universe? For thousands of years, humanity has gazed into the stars searching for an answer. Ancient civilizations built monuments aligned with the heavens. Philosophers debated the existence of other worlds. Scientists developed increasingly powerful tools to explore the cosmos. Yet despite all our advances, one mystery remains unsolved. Does life exist beyond Earth? Today, we may be closer than ever to finding out. Thanks to a remarkable scientific instrument known as the James Webb Space Telescope, researchers have begun investigating distant planets with a level of detail that was once impossible. Among the thousands of worlds discovered beyond our solar system, one planet has attracted extraordinary attention. A planet called K2-18b. Located approximately 120 light-years from Earth, K2-18b is emerging as one of the most fascinating worlds ever discovered. It is a place unlike anything in our own solar system. And according to recent observations, it may possess some of the key ingredients necessary for life. A new generation of discovery. To appreciate why K2-18b is so important, we first need to understand the revolutionary technology that made its study possible. The James Webb Space Telescope represents one of the most ambitious scientific projects ever undertaken. Positioned far from Earth, Webb was designed to observe the universe in infrared light, allowing it to see through clouds of dust and examine objects that would otherwise remain hidden. Its enormous mirror collects faint light that has traveled across space for millions, or even billions, of years. In many ways, Webb functions as a time machine. Every distant object it observes reveals a glimpse of the past. But Webb is not limited to studying ancient galaxies. It can also investigate the atmospheres of planets orbiting distant stars. And that capability is changing the search for extraterrestrial life forever. Meet K2-18b. K2-18b orbits a small red dwarf star located in the constellation Leo. Red dwarfs are the most common type of star in the Milky Way. They are smaller and cooler than our Sun, yet they can remain stable for extraordinarily long periods of time. Because these stars emit less energy, planets can orbit relatively close while still maintaining temperatures that may allow liquid water to exist. This region is known as the habitable zone. Sometimes called the Goldilocks zone, it represents the area around a star where conditions may be just right for life. K2-18b happens to reside within this zone. That fact alone makes it interesting. But the planet's true significance lies in its unusual nature. K2-18b is not a rocky world like Earth. Nor is it a giant gas planet like Jupiter. Instead, it belongs to a category known as a sub-Neptune. Sub-Neptunes are among the most common planets discovered in our galaxy, yet they remain poorly understood because our solar system contains no equivalent example. K2-18b is approximately 2.5 times larger than Earth and more than 8 times as massive. Its composition remains uncertain, but evidence suggests it may possess a thick atmosphere surrounding a vast ocean-covered surface. If true, it would represent an entirely different type of habitable environment. Reading the atmosphere of an alien world. One of the most extraordinary achievements of modern astronomy is the ability to study planets that are unimaginably far away. Scientists accomplish this through a technique called transit spectroscopy. When K2-18b passes in front of its host star, a small portion of starlight travels through the planet's atmosphere before reaching the telescope. Different gases absorb different wavelengths of light. By carefully analyzing these patterns, researchers can determine which molecules exist in the atmosphere. Think of it as reading a chemical fingerprint from across the galaxy. Using this technique, the James Webb Space Telescope detected several important molecules in the atmosphere of K2-18b. Among them were water vapor, methane, and carbon dioxide. Each of these compounds is scientifically significant. Water is considered essential for life as we know it. Carbon dioxide plays a crucial role in planetary climates. Methane can be produced through geological processes, biological activity, or a combination of both. Taken together, these findings suggested that K2-18b might possess a dynamic environment capable of supporting complex chemistry. But an even more intriguing possibility was about to emerge. The molecule that captured global attention. Among the signals detected by Webb was a possible indication of a molecule known as dimethyl sulfide, or DMS. On Earth, DMS is produced primarily by living organisms, particularly microscopic marine life found in the oceans. TSULT, DMS has long been considered a potential biosignature, a chemical clue that could indicate the presence of life. When scientists announced the tentative detection of DMS around K2-18b, the news quickly spread around the world. Could this be evidence of alien life? The answer remains uncertain. Researchers emphasize that further observations are needed before any conclusions can be drawn. Detecting molecules in distant atmospheres is incredibly difficult, and alternative explanations must be thoroughly investigated. Nevertheless, the possibility is exciting. For the first time, scientists may be observing a planet where multiple potentially life-related ingredients exist simultaneously. It is not proof. But it is one of the strongest hints yet discovered. The rise of the Hycean world. The discoveries surrounding K2-18b have also brought attention to a fascinating concept known as the Hycean world. The name combines the words hydrogen and ocean. According to this idea, certain planets may possess enormous oceans hidden beneath hydrogen-rich atmospheres. These worlds could be radically different from Earth while still remaining habitable. For decades, the search for life focused primarily on planets that closely resembled our own. Scientists looked for rocky worlds with similar temperatures, similar atmospheres, and similar conditions. But the Hycean model suggests that life may thrive in environments very different from those found on Earth. A planet does not necessarily need continents, forests, or even blue skies. What matters is the presence of liquid water, energy sources, and stable chemical conditions. If Hycean planets are common throughout the galaxy, the number of potentially habitable worlds could be far greater than previously imagined. That possibility has transformed how researchers think about the search for life. Could life survive there? If life exists on K2-18b, it would almost certainly differ dramatically from anything humans encounter in everyday life. The planet's atmosphere, pressure, and environmental conditions are likely very different from Earth's. Yet life on our own planet has repeatedly demonstrated extraordinary adaptability. Scientists have discovered microorganisms thriving in boiling hot springs, deep-sea volcanic vents, acidic lakes, and frozen Antarctic ice. These organisms, known as extremophiles, survive in conditions once thought impossible. Their existence has expanded our understanding of where life can flourish. If simple organisms can thrive in such extreme environments on Earth, perhaps life elsewhere is equally resilient. Perhaps vast alien oceans harbor microbial ecosystems unlike anything we have ever imagined. Perhaps biology emerges whenever the right ingredients come together. Or perhaps life is exceedingly rare. At present, we simply do not know. A new era in the search for life. What makes K2-18b so important is not that it has already proven the existence of extraterrestrial life. Rather, it demonstrates that we now possess the tools needed to investigate the question scientifically. For most of human history, the search for life beyond Earth belonged to philosophy and speculation. Today, it belongs to astronomy. Powerful telescopes can identify atmospheric gases, measure planetary temperatures, and search for chemical signatures associated with biology. Every year, these technologies improve. Every year, new worlds are discovered. And every year, we move closer to answering one of humanity's oldest questions. The cosmic possibility, perhaps the most remarkable aspect of this story, is what it reveals about the universe itself. Only a few decades ago, scientists knew of no planets beyond our solar system. Today, thousands have been identified. Many are stranger than anything imagined in science fiction. Some orbit 2 stars. Others experience temperatures hot enough to melt metal. Some may be covered entirely by oceans. The universe has repeatedly shown us that reality is often more surprising than our expectations. K2-18b is another reminder of that truth. It may ultimately prove lifeless. Or it may become one of the most important discoveries in scientific history. Either way, it represents a milestone in humanity's exploration of the cosmos. As the James Webb Space Telescope continues its mission, more observations will arrive. More data will be analyzed. And perhaps, one day, a signal from a distant world will provide the evidence scientists have sought for generations. Until then, the mystery remains. Somewhere among the billions of stars scattered across the galaxy, life may already exist. And for the first time in history, humanity has begun looking closely enough to find it. Music swells as the camera pulls away from Earth and into the vastness of space. The search has only just begun.